calcium oxide with activity greater than or equal to 300 milliliters, outsourced or produced independently by the company, is transported to the calcium oxide silo, where the calcium oxide is uniformly fed to the tooth roll crusher by a constant weight feeder, and then be broken into calcium oxide small particles in size of 10 millimeters. The calcium oxide small particles are then lifted to the buffer silo by a bucket elevator, and then be fed to the slacking system by a constant weight feeder through frequency conversion and speed regulation required by the process. The inner wall of the slacker is protected by a corrosion-resistant and wear-resistant lining plate, and the blades are made of corrosion-resistant and wear-resistant materials and fast, replaceable structures. The external composite silicate as thermal insulation material allows the slacking process to be completed at high temperature. The fine slacking process is divided into 4 to 5 staged dual-shaft, dual-drive slackers based on capacity differences. The overflow device installed inside the slacker can extend the slacking time of calcium oxide. Products that meet the fineness requirements overflow to the slacker and next stage, and the crude products continue to be slacked. To produce calcium hydroxide with high specific surface area, BET, greater than or equal to 40, it is necessary to raise the temperature of water for slacking to greater than or equal to 85 degrees Celsius. High-temperature water, converted through heat sources, can serve comprehensive utilization, such as waste heat recovery in the slacking system. When the high-temperature water is pressurized to above 0.3 MPa by a pump, the high-temperature water will be uniformly sprayed onto the calcium oxide surface after the water-with-water-calcium ratio required by process flows through flow meter, regulating valve, and vortex nozzle. Meanwhile, under the action of the pump, the prepared additives A and B are sprayed into the slacker according to the process requirements, with the water content controlled between 5 and 7%. Because the slacker is equipped with dedicated cloth bag dust removal and waste heat recovery device, the slacking process is always in a state of negative pressure without powder spillage. To ensure the calcium oxide to be completely slacked, the slacked calcium hydroxide is lifted into each dynamic sedimentation tank for heat preservation and aging. After 48 hours of aging, the water content of calcium hydroxide decreases to less than 5%, and calcium hydroxide is evenly delivered to drum dryer for drying with clean and hot air at 80 to 110 degrees Celsius low temperature. After dynamic ultrafine separation, the dried calcium hydroxide is delivered to warehouse of bulk finished product and warehouse of packed product respectively. The products and warehouse of bulk product are transported by powder tank transport vehicles and sold externally. The products and warehouse of packaged product are weighed, packaged, and stacked by fully automated packaging machine, and then be transported to the warehouse by forklift for sale. To meet the needs of customers, the production capacity is classified into 10, 15, 20, and 25 tons per hour, and other specifications and models. The on-site space can be designed in straight line, U-shaped, L-shaped, and vertical layouts. The whole production system adopts a dedicated manual and automatic integrated operation and control system for calcium hydroxide, which is manufactured by our company's independently programmed technology, achieving unattended operation and control, automatic tracking and proportioning of materials and water, with dual frequency conversion and dual tracking functions to ensure constant water content. The product quality controlled by automatic PLC is more stable. Fine calcium hydroxide and calcium hydroxide with high specific surface area is used to prepare environment-friendly calcium-based desulfurizer and replace SDS soda dry process desulfurizer. Shandong Juda Technology Group Company Limited will gather its innovative forces to explore the